In this next example, we are going to take a look at how to calculate the index of refraction. So we have Hickory, a watchmaker, is interested in an old timepiece that's been brought in for cleaning. If light travels at 1.9 times 10 to the 8th meters per second in the crystal, what is the crystal's index of refraction? The most important thing to do always when trying to solve physics problems is to write down the information that's been given and to list what it is you are looking for. So in this particular example, we are given the velocity of light in the crystal, which I'm going to label as VC. It travels at 1.9 times 10 to the 8th meters per second. And what we are looking for is the index of refraction, and so I'm going to label that as NC because this is the index of refraction of the crystal itself. Now, one thing that was not given but that I do know that I'm going to need is the constant for the speed of light. That would be labeled as C, and this is in your formula chart, so you don't have to memorize it. This is 3.0 times 10 to the 8th meters per second. So based on the information that I've been given, I'm going to use the index of refraction equation, which states that the index of refraction in your medium, in this case it's going to be the crystal, will equal to the speed of light in a vacuum divided by speed inside the medium that you're looking at. In this case, it's going to be crystal. So I'm going to rewrite this, and I'm going to just plug in the numbers where they belong in place of the variables. So the index of refraction in the crystal is going to equal to the speed of light, which in your formula sheet is 3.0 times 10 to the 8th meters per second, and the speed of light in the medium, which is 1.9 times 10 to the 8th meters per second. Now, when you start doing your division, what you're going to find is that the meters per second here cancels out your meters per second on the bottom, and so there are no units for the index of refraction. This is simply a plug and chug type of equation. So take your calculator, and I'm going to go over again the importance of entering in your the numbers in your calculator as the E function and not times 10. That will throw your answers off. So let's go ahead then and enter in our numbers. We have 3.0, and this is how the correct way to do scientific notation. You're going to hit the second button, which is this yellow one, and then right above the number 7 is a comma, but you'll notice that because we hit the yellow button, we're going to get that second function, which is this double E. And that's the way it looks on the calculator. At this point, all you need to do is type in your exponent. So this, the calculator interprets as 3.0 times 10 to the 8th power. Okay. If you don't trust it, you can go ahead and enter, and then you'll see you've got the correct number of zeros. Going back to our problem, we've got 3.0 divided by 1.9 times 10 to the 8th. If you don't have a scientific calculator, and all you have is just a basic function calculator, what you would do is you would subtract the exponents here. 8 minus 8 is 0. So this is essentially the same as 3.0 divided by 1.9. which is 1.57. So the index of refraction for this crystal would round to 0.6, and there are no units for index of refraction. And that's it.